Ever wondered why rebar steel is such a critical component in concrete construction? Well, my friends, let's dive into it. Imagine you're baking a cake. The flour, sugar, and butter are all important elements, but without the eggs to bind everything together, your cake would crumble. In the world of construction, rebar steel is the egg in our concrete cake. Rebar, short for reinforcing bar, is a steel bar or mesh of steel wires used as a tension device in reinforced concrete and masonry structures. This humble piece of metal plays a pivotal role in ensuring the durability and stability of our buildings, roads, bridges, you name it. Now, you may be thinking, isn't concrete strong enough on its own? Well, yes and no. Concrete is incredibly strong when it comes to compression, meaning it can bear a lot of weight pushing down on it. Picture a giant elephant standing on a concrete slab. The slab might crack a bit under the weight, but it won't shatter. But here's the catch. As robust as concrete is, it's not so good at withstanding tension. Think of tension as a force pulling something apart. If you had a concrete slab and tried to stretch it, it would crack and break. That's because concrete is weak in tension. This is where our hero, rebar steel, steps in. Rebar is excellent at resisting tension forces. When embedded within the concrete, it carries these tension forces, allowing the concrete to do what it does best: handle compression. This clever combination of materials allows us to build structures that can withstand both compressive and tensile forces, ensuring they remain standing no matter what comes their way. So, you see, rebar steel is more than just a piece of metal. It's the backbone that keeps our concrete structures standing. Now that we understand its importance, let's delve into the mechanics of how rebar steel works within concrete. To begin with, rebar steel, short for reinforcing bar steel, is typically incorporated into concrete during the construction process. It's strategically placed within the concrete mold before the wet concrete mix is poured. Once the concrete dries and hardens, the rebar remains embedded within, providing a robust internal skeleton. The main role of rebar steel is to resist tension forces. Concrete, while incredibly strong when compressed, is weak under tension. When a concrete structure is subjected to tension, such as bending or stretching, it tends to crack and fail. This is where rebar steel steps in. Steel is excellent at resisting tension, so it picks up the slack where concrete falls short, allowing the composite material to withstand a much broader range of stresses. This brings us to the concept of composite materials. A composite material is made up of two or more distinct materials that, when combined, produce a material with properties that are different from the individual components. In the case of rebar steel and concrete, the concrete provides the compressive strength, and the rebar steel provides the tensile strength. Together, they form a composite material that is robust, durable, and versatile. Moreover, rebar steel and concrete have similar thermal expansion coefficients. This means they expand and contract at nearly the same rate when exposed to heat and cold. This compatibility prevents the formation of internal stresses that could otherwise lead to cracking. So by embedding rebar steel within a concrete structure, we're essentially compensating for concrete's inherent weaknesses. The result? We get a material that is significantly stronger, more resilient, and capable of withstanding all kinds of tension and stress. And that's how rebar steel works hand in hand with concrete, making it much stronger and capable of withstanding tension. What happens when rebar steel is left out of the construction equation? Let's explore. When we neglect to incorporate rebar steel into our concrete structures, we're essentially inviting a host of potential problems into our construction designs. Concrete, while incredibly robust in compression, tends to be weak when it comes to tension. This is where rebar steel comes into play, fortifying the concrete and allowing it to withstand the tension it would otherwise succumb to. Now, imagine a scenario where rebar steel doesn't make it into the mix. The first issue that arises is cracking. Concrete shrinks as it dries, and without the presence of rebar steel to hold it together, this shrinking can lead to cracks forming. And these aren't just cosmetic issues. Cracks can seriously compromise the structural integrity of a building, leading to safety concerns and potentially costly repairs down the line. But cracking isn't the only concern. Without rebar steel, concrete structures are significantly less stable. The rebar acts as a sort of skeleton, giving the structure a stronger base and allowing it to support more weight. Without this support, the concrete can crumble under too much stress, leading to catastrophic failures that can be dangerous and expensive to fix. And let's not forget about the inability of concrete to withstand tension on its own. When subjected to forces like wind or seismic activity, concrete without rebar steel is much more likely to fail. Rebar steel provides the necessary reinforcement to resist these forces, keeping our buildings standing strong even in adverse conditions. So when we leave out rebar steel, we're not just making a minor oversight. We're compromising the safety, stability, and longevity of our structures. We're opening the door to potential disasters that could have been easily avoided with the inclusion of rebar steel. Without rebar steel, our concrete structures would be much more susceptible to damage and instability. And that's a risk no one should be willing to take. So, what have we learned about the role of rebar steel in concrete? Rebar steel, or reinforcing bar steel, plays a pivotal role in the world of concrete construction. Without it, our skyscrapers, bridges, and even our homes wouldn't be as sturdy or durable as they are. This humble steel bar, often hidden within the depths of concrete, is a true unsung hero of the construction world. The primary role of rebar steel is to compensate for concrete's inherent weakness, its poor tensile strength. Concrete, as robust as it seems, cannot withstand tension on its own and tends to crack under pressure. Rebar steel, with its impressive tensile strength, steps in to shoulder this burden, allowing concrete structures to withstand tension and flex without crumbling. Rebar steel works in harmony with concrete, complementing its strengths and compensating for its weaknesses. Concrete, being excellent at resisting compression, protects the rebar steel from buckling under pressure. In return, the rebar steel provides the necessary tensile strength, enabling the concrete to flex under tension without cracking or breaking. This symbiotic relationship makes concrete an incredibly versatile and resilient construction material. Neglecting to use rebar steel in concrete construction can have dire consequences. Structures may become susceptible to cracks and breaks, particularly under tension or during environmental changes. These cracks can grow over time, compromising the structure's stability and safety. Therefore, using rebar steel is not just an option, but a necessity in concrete construction. But it's not just about adding any rebar steel to the concrete. The size, quantity, and placement of these steel bars matter greatly. Engineers and construction workers must carefully calculate these variables to ensure the concrete structure's optimal strength and durability. So next time you see a concrete structure, remember the unseen hero, the rebar steel, that keeps it standing strong.